Good day, I am Nirajes B. Frondoso from BSCA2, and today I will be solving some CA board problems about cables, centroids, and moment of inertia. The first one is cables. Problem 1. A ceiling of weighing 540 Newton is supported by 3 cables. An isosceles triangle is formed with 2 angles equal to 60 degree. Solve the following using the figure. A. Determine the tension in cable B and C. So PC and PB is equal since the figure is isosceles triangle. So first, we need to moment at A to get the reaction at PB. So the clockwise is positive. So MA is equal to 0. So first is 540, then times 1 minus the PC, which is unknown, times 1.5 minus PC times 1.5 is equal to 0, which is also equal to 180 Newton. So the tension in cable B and C is 180 Newton. B. What is the elongation of cable A if E is equal to 200 MPa, area is equal to 20 millimeters squared? So the formula for elongation is PL over AE. So first, we need to get the force vertical. So force vertical is equal to 0. So the vertical is PA minus 540 plus 180 times 2 is equal to 0, which is also equal to PA is equal to 180 Newton. Then now we can get the elongation. Substitute the values. So the elongation of cable A is equal to 180 times 560 over 20 times 200, which is also equal to 25.2. So the elongation of cable A is equal to 25.2 millimeter. Problem 2. The weight shown in the figure is supported by cables AB and AC. Determine the following. A. If weight is equal to 85 kN, what is the tension in segment AC? First, we need to get the force horizontal or Fx. Fx is equal to 0. So TAC cosine the given theta, which is 12.485 degree. So how do we get 12.485? So it is tangent arctan times 15.50 over 70, which is equal to 12.485 degree, minus TAB cosine 17.223 degree. So the 17.223 degree came from arctan 15.50 over 50 is equal to 0. Then TAB is equal to 1.022 TAC since TAC is also unknown. Next is we need to get the force vertical. So Fy is equal to 0. TAB sine the given angles, sine 17.223 degree plus TAC sine 12.485 degree minus the kilonewton, which is 85 kilonewton, minus 0. So it will become 1.022 TAC sine 17.223 plus TAC sine 12.485 minus 85 kilonewton, which is also equal to 163.84 kilonewton. So our TAC is equal to 163.84 kilonewton. B. Total length of the cable. So to get the total length, we just need to use the Pythagorean theorem. So the total length is equal to square root of 50 squared plus 15.50 squared plus the square root of 70 squared plus 15.50 squared, which is also equal to 124.04 meter. So the total length is 124.04 meter. Next is centroid. Problem 1. The centroid of the shaded area in figure is required to lie on the y-axis. Determine the distance b that will fulfill this requirement. First is we need to get the a1. So a1 is equal to 1 half and then 80 times 40, which is also equal to 1,600 millimeters squared. Then our x1 is equal to negative 2/3 times 80, which is also equal to negative 160 over 3 millimeter. Then we need to get the other side, which is the a2 and x2. For a2, our given is 1 half times 60b, which is the unknown, is equal to 30b millimeter. Then for x2 is equal to 2/3 b millimeter. Then ax is also equal to the summation of ax. So 0 equal to our a1, which is 1/6, times our x1, which is negative 160 over 3, plus our a2, which is 30b, times our x2, which is 2/3 over b. So it will become 2 times 30 over 3 b squared is equal to 160 times 1,600 over 3, which is also equal to 65.32. So our b is 65.32 millimeter. Problem 2. Determine the coordinates of the centroid of the area shown in figure with respect to the given axis. So first, we need to find the a1, a2, x1, x2, y1, and y2. So to get that, our a1 is 1 half times 6, which is given, and then 9, which is also given. It is equal to 27 inches squared. For x1 is equal to 1/3 times 6 equal to 2 inches. For y1, 2/3 times 9 is equal to 6 inches. For a2 is equal to 1 half pi 3 squared, which is equal to 14.14 squared inches. And then for x2, which is also equal to our r, equal to 3 inches. So y2 is equal to 9 plus 4 times 3 over 3 pi, which is equal to 10.27 inches. Next is let's get the area. To get the area, we just need to add our a1 and a2. So a is equal to a1 plus a2. Our a1 is 27 plus a2, which is 14.14, which is equal to 41.14 squared inches. Next is to get what is missing or what is unknown. So first is we need to use the area, which is 41.14 x is equal to 27 times 2 plus 14.14 times 3, which is equal to 2.34 inches. So the first answer is 2.34 inches. For ay is equal to summation of ay, 41.14 y is equal to 27 times 6 plus 14.14 times 10.27, which is our y2, is equal to 17.47 inches. So our coordinates of the centroid is 2.34 and 7.47. Next, moment of inertia. Problem 1. A hollow square cross-section consists of an 8 inches by 8 inches square from which is subtracted a concentrically placed by square 4 inches by 4 inches. Find the polar radius of gyration with respect to a z-axis passing through one of the outside corners. So first, we need to get our I. So I is equal to 1/2 times our base and height of the bigger square. So BH cube minus the base and height of the smaller square, which is BH cube, is equal to 1 over 12 times, then substitute the given, which is 8 times 8 cube minus 4 times 4 cube, which is also equal to 320. So our I is equal to 320 inches raised to 4. Next is to get our area. So for area, we just need the given, base, and height. So area is equal to a squared minus 4 squared, which is equal to 48 inches squared. So remember that I is equal to I plus AD squared is our formula to get the other I. So substitute the given. So 320 plus 48 times 4 squared. So our I is 1088 inches raised to 4. Next is to get the polar moment of inertia, which is missing or unknown. So J is equal to I is equal to Ix plus Iy. So our J is also equal to our I. So Ix plus Iy, which is 1088 plus 1088, is equal to 2176 inches raised to 4. So that's the first answer. Then the next one is the radius of gyration. So kz, then the formula J over area. So square root of J over A is equal to our J is 2176 over our A, which is 48, which is equal to 6.733 inches. So the other answer is 6.733 inches. Problem 2. A rectangle is 3 inches by 6 inches. Determine the polar moment of inertia and the radius of gyration with respect to a polar axis through one corner. First is we need to find our Ix. So the formula for Ix is base times height cube over 3. So our base is 6 and our height is 3. So 6 times 3 cube over 3 is equal to 54 inches raised to 4. So for Iy, our formula is hb cube over 3. Our height is 3 times the base, which is 6 cube over 3, which is equal to 216 inches raised to 4. Then we need to get the polar moment of inertia. So the formula is J is equal to Ix plus Iy. So our Ix is 54 plus the Iy, which is 216. So 54 plus 216 is equal to 270 inches raised to 4. So that's the first answer. Then the next one is the radius for gyration. The formula is square root of J over A. So our J is 270 over our area, which is 3 times 6, which is the height and base. So, square root of 270 over 3 times 6 is equal to 3.873 inches. So, the radius of gyration is 3.873 inches.